Alright, this is a video for the lab 5 slides, and it's gonna be a short video because so from last lab you should have this results from the nylon bar. Okay, so in this lab we're gonna change the material of the bar, and we're going to add a new coordinate system. So that'll be lab 5 and a new coordinate system, and we're going to change the whole model into the new system as well as the bushings. Okay, then we have to solve it again to refresh the results. Then at last we're going to show you how to measure the distance for the hand calculation, which is this. Alright, as you can see, we have 4 distance we have to measure for the hand calculation. Alright, so let's go back to NX. Then I have the model from lab 4 on the screen. Then let's go to the fan. So the first step is to change the material, and at this point you should be pretty familiar with that. So just find the nylon bar and double click monkey wrench. So it's not in here. Just choose from the material, and that'll be polyurethane soft. Okay. Alright, and the next step, I'm going to change the whole model into a new coordinate system. So to insert a new coordinate system, we're going to here insert, and it's in model preparation. It's called coordinate system. Alright, so for the new coordinate system, we want the z-axis is the same as this one. Let's see if we can turn on the old one. Alright, z stays the same. The only thing change is the well, a couple of things change. The origin we'll put in here. Okay, and the axis, the y-axis will be perpendicular to the C bar here. This way, the model is relatively symmetric in terms of the handle and those two pieces. The blade itself is not very symmetric. So that'll give us the x-axis along the C bar. Alright, so that brings us the method to insert the coordinate system. So z we know, and we know the origin as well as the x-axis. The y-axis is sort of hard to pick. So z-axis, x-axis, and origin. Alright, so the origin point in the middle here. Z-axis, you can either pick from this menu, or you can pick the coordinate system you just saw. And the x-axis is along the bar, so you would like to use 2 points to define the vector from this point to the end point. And that'll give you a review of the new coordinate system. So this one looks good. Let's just say OK. Alright, and sometimes, not always, you might encounter one problem is when you insert a coordinate system, say 3 objects, and as you can see, my z is already selected. If you pick a point, I'm just doing random things, okay, and pick another vector, because z is already selected when you open the command, you can't click OK, even though you have 3 objects selected. So just beware that if you encounter this problem, just refresh it, change it to 3 objects that nothing is selected, then pick them. Okay, let's try this, then you will have your OK button come back. Alright, that's just a little bit troubleshooting. Alright, so we have the new coordinate system. The next step is to change the model into the new coordinate system. And when we say change the model to a new coordinate system, we are actually changing the coordinate system for the nodes. because the whole fan model is based on the nodes. So what we do here is we go to edit, and we're going to modify the coordinate system for the nodes and assign them a nodal coordinate system. And the term is called displacement coordinate system. And the object is all the nodes. So before I select, I want to make sure all the nodes are on the screen by hide and let's show the meshes again. This way I know all the nodes are on the screen, and this box select everything. I should have more nodes than you because my mesh somehow is finer around the holes. And the coordinate system is not global, it's a Cartesian system we just made. And if you open the folder in the navigator, you can select it from here, which is what we did in the slides. Okay, if you click, it's going to select that. And another way is you can pick in the graphic window. Alright, so that's the coordinate system. Then even though nothing happened, but the whole model now is on the new coordinate system, except one thing is the C-bush. So you remember we gave them a coordinate system override, which is in here, edit mesh associated data, and the coordinate system type was absolute. Now we're going to change that to a Cartesian system, which we just created. Okay, say okay. So the nodes and the bushings, they're all in the new system, and that'll be all the work you have to do in the fan. The next step, just go back to the sim. Okay, we don't have to worry about the force because we define the force by 2 points, and the 2 nodes they haven't changed any position yet, so that's good. Just in case if your force was on those directions, X, Y, Z, you might need to change the working coordinate system, but that's not on our model. So in terms of our model, you just go solve again. By the way, this button is the same as right click and solve here, okay, and say okay. So it'll take a while, and after that you should get the displacement of 1/4 inch, 0.249. That's the maximum displacement. And the F6, you will have very small force on the Y direction. Take a look. All right, now it's 1/4 inch, and let's look at the F06. Go to the bottom and come up. So your bushing force on the Y direction, this is actually the new coordinate system. It's also we call that Y prime system in the class, and you will have close to 0 on the Y direction for those 3 bushings, and the bottom one here in my case are the 2 bushings between the 2 handles. They would have some Y components. And also if you look at the SPC force, the 2 user-defined constraint on Z direction would be much smaller than before. That is because we changed the material to a much softer material. And other than that, the axial force should stay the same because the force and the reaction force, the force is not determined by the Young's modulus. It's rather the distance, okay, the geometry of your snip. Alright, so that's the F06 and magnitude on the displacement. And lastly is the measurements. Let's go to the bottom. So the measurement, tool. Let's see, go to the fan. Okay, why do we need to measure things? Because the hand calculation, we have this D1, D2, and the D3, D4 for the equations. Once you have those four distance, you can get all the bushing force out of the model. So you will have your analytical solution by hand calculation, and then compared to NX solution, you should get within 5%. I'd say within 2%. Okay. All right. So how do we measure the distance? You can measure on the CAD as Dr. Zarda did in the class. You can also measure from the FEM. So that's the measure distance tool. You want to project on a vector. So the vector is the y prime direction. Okay, I think some people click on the coordinate system, but that's a system with 3 vectors. You have to define which one. So just click on the y prime direction. The starting point, you take a look from the bottom. Let's do it from the 10 pound, then you get force right away. So from the bottom point to this point between the handles. So the bottom point is here. If you can't make sure which one is which, you can hide a half, then that's the bottom point. Then F8. Okay. So this point doesn't matter which one, top or bottom, because it's projected on the y prime distance vector. So that is your D4 and D3. So this is the second point. The end point, we can change the start point to this point. That is a D3. Okay. Then D2, D1, you can do that. It's pretty easy. Alright, so I guess that's the end of this video, and I hope you can find a really good result. Thank you.